So in this case, what we're going to do is we're going to determine the angle of the angle measure using the tangent ratio. So we have a triangle right here that's a 9, 12, and 15 triangle. So we're going to determine the angle of theta. So we're going to use the tangent ratio, which we know from our previous videos and from in-class work that tangent is the length of the opposite side over the length of the adjacent side. So the first thing we have to do is identify the opposite and adjacent side. Now, we know that the hypotenuse is directly across from the right angle, so that side length that's indicated by the 15, we know that that's the hypotenuse, and we're not going to use that right now. We have to identify the important parts for determining the angle theta by using the tangent ratio. So we need to place the opposite and the adjacent. And remember, if this is the angle, if the angle theta is at the very top, we know that directly opposite to that is the opposite side, so the 12. And the only side left is the adjacent side, which is 9. So determining the tangent, the measure of angle of theta is an important piece. So we have to use the opposite, which is the opposite side of theta, which is 12. So I'll just fill that in. The opposite goes in the numerator. In the denominator goes our adjacent side, which is 9 in this case. Okay? So now that we know that our ratio is 12 over 9, we do some division here. 12 divided by 9, which should give us around 1.3 repeating. Now, to determine the actual angle measurement, we have to take the inverse of tan. So a lot of times on your calculator, what you have to do is you have to, once you get that 1 3/10 repeating, you have to hit second function tangent, and that'll give you the arctan or the inverse of tan. And when I do that on my calculator, I get 53 and 13/100ths. 53.13 degrees is the unknown angle.